All right, this is the last video of this chapter. This has been more videos than we normally do on chapters, but on this chapter, I wanted to break things up a little bit and make sure that you had plenty of opportunity to go back and watch a video without having to do a lot of back and forth through the video to find the places you need to talk about. So in this video, we want to talk about enumerated data types. Now, I will tell you this is used a lot in C++. In fact, I find that when people first learn about enumerated data types, they go a little crazy with enumerated data types because it makes development pretty easy and it makes reading your code even easier. And they just make sense right out of the gate. So kind of keep that in mind. We want to use them. Be careful you're not going too crazy with them. Okay, so with an enumerated data type, it's a type that is programmer-defined data type. So that means you're going to define it, and it consists of values known as enumerators, which represents integer constants. Now, real quick, let's just kind of say this is going to be the part that's probably most troublesome with enumerated data types. And the reason you're going to find it to be difficult is sometimes they act just like integers and sometimes it doesn't. And getting used to when it does is great, but you're going to have to definitely deal a little bit with when it doesn't. So let's talk a little bit about that. Enumerated data types. Here's a great example of a enum. By the way, that's how we start out talking and how we classify that we're about to create an enumeration. We use the enum word there. And then we give it a name. In this case, it's day. And then we specify what our enumeration is going to be. The thing to get is that there are no quotes. No single quotes, no double quotes, no quotes whatsoever. So you got to remember that. In fact, I'm going to erase these because I don't want anyone to get that confused. There are no quotes, double quotes. Oftentimes in our enumerations, they will be capitalized. Again, you may find that whatever organization you're working for may have rules around this. I have worked in both. I don't necessarily prefer to capitalize enumerations, but it does make it a little bit more sense because, again, you can't really modify them once they're created. And we'll talk about that in a moment. But in this, we can see that we have an enumeration where we've got Monday, Tuesday, Wednesday, Thursday, and Friday in it. They do have braces around it. So again, make sure you have your braces. Oh, and then our friendly semicolon. Make sure you have all those pieces. So here, this slide is again saying nothing's enclosed in quotes because they're identifiers. So they don't need to be in quotes. In fact, they don't necessarily, like Monday does not translate exactly to Monday. And if you tried to use that with the cout, you're not going to get necessarily what you think you should get. But we're going to talk about that here in a moment. So once you've created an enumeration data type in your program, you can define the variables of that type. So example, we can now say and let's go back up here. Remember, the name that we've given this enumeration is day. And so that means that we can say now, hey, we want to create a variable of type workday. And we're going to call it workday, but it's of type day. Sorry about that. So, and that's what this is saying. This statement defines workday as a variable of type day. Makes sense. We may assign any of the enumerators, Monday, Tuesday, Wednesday, Thursday, or Friday, to this variable. So, in fact, we're saying this workday is now going to be filled with Wednesday. So far, so good? Great. So, Professor Waits, what is an enumerator? Well, it is an integer constant. And this is where it gets a little scary. Because if we go back to where we defined it, here we go. Behind the scenes, this is becoming a 0, 1, 2, 3, and 4. That's what's happening behind the scenes. So internally, the compiler assigns that integer value beginning at 0. And that makes this really easy, yet really complicated real fast. So let's figure out why that is. So when we're using the day declaration, the following code, cout Monday space Wednesday. And this is a little typo. There's supposed to be a double quote as well. Friday in line, right? So we're putting spaces in here to do this thing, right? So what does that produce? Well, like I said, behind the scenes, it's going to give you the integers. Great. Now, how do I complicate this? Well, because you can't assign integers back to an enum. So like this, 3, which we know stands for Thursday. You would think you could do that since behind the scenes it knows that Thursday's 3, but you can't. So this will produce an error. You cannot do this. That's where it gets a little complicated. This is where I was saying that you're going to have to get used to where you can kind of swap it out for an integer and where you can't. Now, one of the things you'll always find with C++ is there is 100 ways to do something, and then there's usually some way to do what you want to do. So if you want to do that where you're using a 3, maybe you're running through a for loop and you're using a numeric value, and at some point that numeric value does need to go back into your workday, you can do that rather simply by using this static cast, and you're using these brackets to say what you're static casting it to. Now, the compiler, when you do that, says, oh, gotcha. We're going to actually take 3 and we're going to go backwards and figure out what the day is. Because the problem is with 3, it's saying 3 could be Thursday, or maybe we have another enum somewhere and it could be that enum. How do I know? So that's why we're saying the static cast, but you have to tell it what the static cast is of type, and it's day. So it goes, oh, okay, because it's a 3 and it's supposed to be a day, we now know that it's Thursday, and I can shove that right here into workday. So that's why it does that. Let's go back to red, because red tends to stand out on these white pages pretty nicely. So again, let's make it a little bit more complicated. You can assign an enumerator to an int. There you go. Oh, now we got black. Let's go. Again, red is the easy color to see on these screens. So now we've got int x, and we can assign Thursday to x, which means now x is actually equal to 3, because it's going to do the translation. That's because the compiler knows that this is of a type day, which behind the scenes reverts back to a number. And because you're trying to put this into x, it's easily able to go, okay, I get it. You want the 3 in there. Okay. Not so easy backwards. And so that's why this works great. And you can get Thursday assigned to x, which means x equals 3. Now, when it comes to enumerators, you can compare them. Remember that they're going to compare just like integers. And so we know that Friday, I believe, is 5 or 4, something like that. And Monday, I believe, is 0. So obviously, Friday is greater than Monday. Makes sense. Nice little program here. We've got number of days equals 5. Remember, and by the way, in your homework, remember when you are setting up an array, this is really in academia the right way to do it, because we always want this. The fact that when it comes to arrays, you're often going to have to use the number or the size of the array quite a bit. It's just best to go ahead and set up that constant with that number. So that way, if one day you're coming back and you need to change this, maybe right now we're going Monday through Friday. What if we wanted to go from Sunday to Saturday, right? Then we could easily change this to 7, and our code is updated everywhere. We don't have to miss something. We don't have a bug that shows up because we missed one of those sizes. So try to get used to, really, not try, but you got to get used to it. Like I said, really getting used to this idea that you have to use the constant first. All right. So one of the nice things about enumerators is because behind the scenes it does translate to an integer. You can use them as in your for index. So this is actually saying index equals 0. Continue to go as long as index is less than or equal to Friday, which happens to be, well, let's see, Monday, Tuesday, Wednesday, Thursday, Friday, 0, 1, 2, 3, 4. So there you go. And because again, as long as we're going integer to the enum, we can do that, not enum to an integer. Excuse me, I got that backwards. We're going enum to an integer. We can do it. We can't go from integer to enum. So let me write that out here, because as you saw, it's just that simple to get it confused. You can go from enum to an integer, but you cannot go from integer to enum. Not without casting it, as we saw that static cast. You cannot do this. You can do this. So that's why in this, it does work. It does allow us to, like I said, go and do the index plus plus because we are going from an enum to an integer. So we're increasing, and it knows that, okay, that integer, when it's 1, translates to Tuesday, and so forth and so on. Now, in this, though, one of the things we just talked about, that int to enum, if somewhere we needed, let's say in here for some reason, we wanted to assign a variable, we had a variable out here of type day. And maybe we wanted to, this for index at some point it's going to stop on a certain day, and we wanted to record that. We could not do our day variable. Let's go day var equals index. That would not work. We would have to do the static cast here. So kind of keep that in mind. Here is the example of our code. Ooh, don't forget set precision. We've used that before. That does this. That adds and makes sure that they all, because like in here, if this set precision wasn't set, it would only show 1525. It would not show the .00. This set precision is what does the 00. So this just shows, again, a little bit more detail about that, where we are using index, but it is translating to whether it's Monday, Tuesday, Thursday, Wednesday for, same thing. All right, so here we have an anonymous enumerated type. So up to this point, we have been, where'd it go? We have been saying our enum is of type day. Well, now we're not going to say any of that. Now, behind the scenes, we can do this because, like I said, and all said and done, this is coming back to an integer, right? So how do we make use of that? What's the point of that? Okay, so this slide does not talk about it. So let's go back. Let me talk a little bit more about this. And the reason being, For example, in program time, we have declare the enumerated type as. They may talk about it. I really thought that they were going to go into more detail on that, but let's just take in consideration that they don't. And let me take a moment to explain. There's two things you need to know about anonymous enumeration types, right? And the first is that you can do that, and the second is that you can actually assign values to your enums, right? So up until this point, we have, we can go way back here and we can say when we created this in memory, it created it as 0, 1, 2, 3, 4, right? And that's great, but we can actually go rogue and we can say, no, I want Monday to be, let's say, 0, and Tuesday to be 5, and Wednesday to be 10. And this is how you would do it, by the way. You would literally put the equal sign and put the number you want it to represent. Okay. Now, of course, I don't know that this makes sense why you would do it here, but let's just say you did. Or you know what, even better, let's go ahead and try to create a situation where we'd want to do that, right? When you do anonymous enum types, the reason why you're doing it is you're essentially wanting to set up constants and you're trying to do it an easy way of doing it, right? So in this case, let's say we want to say enum and we want to say Celsius equals 0 and Fahrenheit equals, and if I didn't get that right, you have to forgive me, 32, I believe, right? So now we just created an enum where Celsius and Fahrenheit, the freezing point, is set. So depending on, let's say this was part of our app that we had. Let's say the user has set the settings that we've created that they are Celsius. Then from here on out, whenever we talk about the freezing point, we will use just Celsius as the parameter, and it will know to automatically put 0 in there. Or if they're in Fahrenheit, right, they want to use Fahrenheit, then we know we would use 32. And so all you're doing with an anonymous enum is it's a way to easily set up constants. We could have said constant int Celsius equals 0. That would have worked too. But because we have this, because we have more than one, the enum just felt comfortable. And oftentimes when we make enums, even though you could put anything you want here, we often, even if it's anonymous, we still group them by some kind of grouping, right? In this case, it's, temperatures, right? If we had a long list, sometimes you'll see this when people are doing error codes, right? So behind the scenes, they want to have an error code that covers all the things that could go wrong. And so they have an enum. And we would say out of memory equals 0. And actually, we wouldn't even do that. We tend to start with bigger numbers. So we'll say 100. Out of memory is 100, blah, blah, blah. Maybe because we're trying to be thoughtful that, down the road, we may come across more error codes. So what we're going to do is we're going to just be thoughtful about that. We're going to say the next one for us is, let's say, file not found equals 110. And we do that because we want to make sure that we've given some space in here in case we need to come along at some other point in our code. After we've ran this application for a while and people come back and go, oh, this thing keeps crashing. And you go, oh, that should be an error code. You now have space maybe in between to add, 101, so forth and so on. And yes, you're asking all the right questions. You're saying, Professor Waits, but why can't I just add it to the end? You could. Again, this is all how you, as a developer, stylize your code and the style you add to things. But what I'm saying here is you can assign a number to something in an enum, and that's the exact reason why you would want to have an anonymous enum. Now, hopefully, whenever we find program for 1110, we'll go over that. So again, back to where we could run into issues when it comes to enums and whether they're integers or not. You can run into problems when trying to perform math operations with enum. So we know we can assign Tuesday to day one. And in our mind, since it's an integer, you would think you could say, well, then day one plus one should be Wednesday, would be shoved back in here. And it won't. Now, again, you could first do this and then static cast it, because this works. This is fine. It's reassigning it to here that's the problem. So that's why you're going to get an error. But you could static cast some of this and get it to where it's nice and neat. In fact, that's where, if you were trying to do something like that, that's exactly how you do it. The third statement will not work because the expression day one results in an integer value 2, which we know, but you cannot store that into an enum variable. You have to then static cast it. Using math operators with enum variables. So this is exactly what we just talked about. You can do this. Oof. We can do this, but we need to then static cast it to the type of day. Type of day. Now, we've already talked about this. This is just an example of it. But again, we see that we have the fact that we have numbers of days is 5. We can then use this to assign values in the sales array. And this will translate, these enums will translate back to the integer. So this is actually saying sales of 0, sales of 1, sales of 2, sales of 3, and sales of 4. Hopefully by now you kind of caught on to that though already. I mean, that we've discussed that numerous times. Again, this is another example that this code will not work. And why is it not going to work? So let's take a look at it. So we've got our day called workday. We have workday equals Monday. And keep going as long as you are less than or equal to Friday. And then we are saying workday plus plus. So what's going on? Oh, that's why. I love it. Sometimes it even see, as you can see, sometimes even I get confused because some of it's just weird how sometimes it works correctly and behind the scenes it works. Again, it comes down to whether you can take an enum to an integer or an integer to an enum. The problem here is the workday can't be. We're trying to set a workday by adding. So remember, what we've done here is we're actually saying workday equals workday plus 1. Remember, we can do this, but we can't do this. So even though we've been very fancy about just doing that, the problem is while we could do this, we need to static cast it back. So that's exactly what's going on here. We have to make it a little bit more complicated because we have to add the 1 to workday, but then static cast it back. That's why it wasn't going to work. So let me repeat that. Remember, what's going on here is this is actually saying work day equals work day plus 1. And while we can do this all day long, we cannot do this part. That's why we have to static cast it. I told you, at some point, these enums are great, but sometimes they do get a little complicated. Most people will use enums for what we've been seeing a lot, where we're using it as an indexer. As an indexer, you'll see that, but here you're just not going to see it as often because, again, while this makes sense, most developers go, this is just too much. I'd rather just use a straight up integer variable because this makes my code look a little bloated. So again, you can use it and feel free to use it, but this is where it's going to get a little messy. Now, this is that program 1110. And so far, I'm not seeing any anonymous enums. So interesting. All right. Another thing about enumerators, they must be unique within the scope. Now, let's remind ourselves a scope essentially is between curly brackets, right? I even typed the wrong one here. So let me get rid of that. Delete. So scope, it's all this. Now, remember, you may have something here that has an open curly, and way down here is a closed curly, and maybe you have, let's say, a for loop with a curly here. Remember, in scope goes from its curly to its bottom curly. So scope lasts for all of this if something's up here. Where it doesn't last is, remember that if you've got something in here, then the scope is only here, and this will not. Let's say you set up a variable in here. This will not translate outside of these brackets. And the reason why I bring that up is, again, because you got to appreciate that when you are using enums, they have to be within, you cannot have, they have to be unique within the scope, right? So here, if this was in a brackets, you can't do this because it's not going to know which Roosevelt you mean. Do you mean the vice president one or the president one? Now, we're going to show you here in a way to kind of do that. And like I said, there's usually always some way to do it. Maybe long and tiresome, but always, right? So yeah, but for the most part, we can't because these two enums are in the same scope. Now, if this enum was in this scope and this enum was in some other function scope, all day long you can do that, right? It's when they're in the same scope. So in C++11, they came along with this idea of strongly typed enums. And the idea here was because maybe as an enum you want to have more than one. And it's not really why they did it, but they did it more for the control of making sure the enum at the compile time was a little bit smarter. Not something I'm going to get too far into on this presentation, but for us, what it means is if you wanted to, you could have enumerators now with the same name, but when you want to make use of them, you're going to have to fully qualify them with this double colon to say which of Roosevelt are you talking about. And you can also use it when you are casting using a static cast. Again, if you don't do this, right? If you don't do this, it doesn't know which Roosevelt you're talking about, and compiler will give you an error. So you got to make sure that you are fully qualifying it. All right, welcome to the last slide. So declaring the type and define the variable in one statement. All right, so you can declare and enumerate data types and define one or more variables of that type in the same statement. So, and essentially, this is very much what we've been doing before, where we said int x equals 0, right? Excuse me. Really, what they're saying here, sorry about that, is they're saying we're going to declare the type's name with that. So this is more of we're going to set up what goes in this enum, but we're also on the same line going to give a variable name. So this variable name can then just be used rather than setting this up and then saying car, sports car. We're doing it all in one line. So that way sports car is ready to go out of the gate and you can go ahead and make use of that enum. All right. So this is the last video of the chapter. We've come to the end of the chapter. You've got a couple of homework assignments that utilizes pretty much everything that's in these chapters. If you have any questions, make sure you reach out to me. I try to do it sooner than later, so that way I have plenty of time to answer anything. And always make sure, if you're not unsure of a topic, please go back and watch that video again. Oftentimes, you'll pick up things on the video a second time, and that will help you. And then if you are still in need, make sure when you shoot me a question, try to be specific. Don't say something like, I don't get enums, because that's not going to help me. And I probably would just, say, hey, well, go watch the video again. Let me know what specific question you might have about enums. All right, with that, I appreciate your time and hope you have a great rest of the week doing the homework. See you soon.